Topic we have before us today is plane shapes. Plane shapes, you're already familiar with it. It's just that today's lesson will be a few addition here and there. What are the lesson objectives we seek to achieve today? By the end of this lesson, you should be able to identify parallel and perpendicular lines. You should be able to solve quantitative aptitude problems on plane shapes. And you should be able to state some properties of triangles, including equilateral, isosceles, and right-angled triangle. Lastly, you should be able to solve quantitative aptitude problems involving triangles. What are parallel and perpendicular lines? You can see these are called parallel lines. They are straight lines that do not intersect at any point. When you say intersect, that do not meet, okay? And the meaning of this arrow means is continuing, is going, is continuing, all right? They are straight lines that do not meet at any point. That's why they are called parallel lines. The next we have a perpendicular lines. Look at them. Perpendicular lines. Why are they called perpendicular lines? The two lines must cross at right angles. This is a right angle, a right angle, a right angle, a right angle. So the two lines must cross at right angles to each other. That's why they are called perpendicular lines. Now let's look at properties of a triangle. You know how a triangle looks like, having three sides. Look at it, and three angles, 1, 2, 3. It has three sides, it has three angles. That's a triangle. So let's look at types of triangles and their properties. I have different triangles here: equilateral, isosceles triangle, scalene triangle, then the right angle triangle, also called right triangle. So the first one we are looking at here, okay, look at these triangles. Equilateral triangle, look at them. You can see these three sides have the same marks. 60 degrees, 60 degrees, 60 degrees. All angles are equal as well. So what are the properties of equilateral triangle? 1, it is a regular polygon with three sides. 1, 2, 3. 2, it has all three sides equal. That's why you keep having these lines on the three sides. Okay? It means the three sides are equal. 3, it has all three angles equal to 60 degrees. 60, 60, 60 degrees. We are still looking at types of triangles and their properties. The next triangle I have is the isosceles triangle. Look at the mark, only on two sides. What does that mean? It means it's only two sides of the triangle that are equal. 1, it has two sides equal in length, and these are the sides 1, 2 that are marked. 2, the angles opposite to the equal sides are equal. The angle of this line and the angle of this line, these two lines that are equal to each other. 3, the third side which is not equal to the other two sides is called the base. Look at this side that has no mark. Okay? The third side which is not equal to the other two sides is called the base. The base. We are still on types of triangles and their properties. The next one I have is scalene. The scalene triangle. What are the properties? 1, it has no equal sides. None of its sides is equal. 2, it has no equal angles. None of its angles is also equal. 3, it has no line of symmetry. Okay? 4, the angles inside this triangle can be acute, okay, obtuse, or right angle. It has different types of angles inside it that are not equal to each other. The angle could be acute, it could be obtuse, it could be right angle. Then the last one, we have the right angle triangle that can also be called the right triangle. Why do we call it the right angle triangle? 1, one angle is always 90 degrees or right angle. When you see this square-shaped angle, it's called right angle. And that's why the triangle itself is called right angle triangle. That right angle is 90 degrees. It must always be at this corner. Okay, look at the next one too, the next diagram. 2, the side opposite of angle 90 degrees is the hypotenuse. This side, which is always the longest side, is always called the hypotenuse. 3, the sum of the other two interior angles is equal to 90 degrees. Look at angle A and angle B. If you add the two angles together, they must give you 90 degrees. 4, the other two sides adjacent to the right angle are called base and perpendicular. What are the two sides adjacent to the right angle? 1, 2. This is the base, this is the perpendicular. Let's look at quantitative aptitude problems on plane shapes. I have a prism here, a prism. How many plane shapes can you see in the above prism, which is a solid shape? 2, name the plane shapes. How many plane shapes can you see? You know, out of solid shapes comes plane shapes. It is the combination of plane shapes that give us solid shapes. I can see it. Okay, let's look at our answers. 5 plane shapes. That is 1, 2, on this side 3, on this side 4, and under 5. So the plane shapes are triangles. 1, 2. The one here facing me and the one facing this side. 2 triangles. Then 3 rectangles. The one here facing this side, the one here facing this side, and the one under. 2 triangles and 3 rectangles can be brought out of this prism. Also, we are still on quantitative aptitude problems on triangles. Yeah, look at this question. What number will replace question mark? I look at this diagram. I had to think. That's why it's called quantitative reasoning. Okay? I checked. How did these 3 numbers achieve the middle number? So looking at the diagram, I added all the 3 numbers around the triangle and it gave the center number. 6 plus 7, 13, plus 9, 22. 12 plus 3, 15, plus 5, 20. So for this now, we don't know the number here, but the 3 numbers around this triangle should give me 13. Okay? Oh, 15. 15 is the middle number, not 13. 7 plus 5, 12. Plus the missing number will give me 15. What do you think I can get add to 12 to give me 15? It's 3. So the missing number is 3. You need 3 more to make 12 15. So the missing number is 3. Let's look at another question. What number will replace question mark? This one gave me a bit of thinking. I tried addition, it didn't work. I tried subtraction. I tried multiplication until I came to an answer. So quantitative reasoning are not, sometimes you need to sit and check and think deeply, maneuvering the different basic operations: addition, subtraction, multiplication, division. You can even check squares of numbers, and square roots. Looking at the diagram, find the square of the upper number and subtract from the addition of the two lower numbers. You can see that one is a bit technical. Look at the missing number is in the first triangle. So I need to look at what was done in the second and third triangle. For the second triangle, the square of 5 raised to power 2 will give me 25. That is 5 times 5. Then the two lower numbers, 4 and 2, I added them, 6. When you take away 6 from 25, 25 minus 6, it will give us 19. For the third triangle, I took the square of 6 raised to power 2, which is 6 times 6. It will give us 36. I added the two numbers below, 9 plus 6, 15. I took away 15 from 36. 36 take away 15, it will give me 21, which is the middle number. So let's go to the first triangle, in which we are looking for the missing number. Okay, 3 raised to power 2 is 9. 1 plus 2, 3. When you take away this 3 from the 9, 9 minus 3 will be 6. So the missing number is going to be 6. You can listen to the explanation again. Let's look at another exercise. From the diagram above, answer the following. Look at, is our right angle triangle. 1. What is the name of the triangle? I mentioned it already. 2. If according to the properties of the above triangle earlier shown, the sum of angles A and B will be equal to 90 degrees, what would be A if B is 60 degrees? Remember, in the properties of a right angle triangle that I taught you, the addition of these two angles must give us this 90 degrees. So if B is 60 degrees, what do you think A will be? What will you add to 60 degrees to give you 90 degrees? Let's check the answers. 1. The triangle is right angle triangle. 2. If B is 60 degrees, take it away from 90 degrees to get A.